Hello, guys. I hope everyone had a great weekend. It's Miss Richardson. Oh, I'm just looking at my hair. It's a mess. All right. So the first thing we're going to review is turning improper fractions into mixed numbers. So fractions, that line that, when you look at this and say this is a fraction, that line right there is actually a division. It's just a fraction is basically a division problem. So if you're trying to convert it to a mixed number, you're going to take that top number, which is the numerator. Of course, I should use the correct terminology. You're going to divide it by its denominator. So 2 will go into 5, 2 whole times, and 2 times 2 is 1. So then that remainder becomes the numerator of your fraction. So 2 whole times with a remainder of 1, and your denominator never changes. So 5 halves is the same thing as 2 1/2, 2 1/2. All right, what about the next one? What about 12 fifths? So 12 goes in the box, 5 goes outside the box. How many times will 5 go into 12? It'll go 2 whole times with how many left over? The remainder is 2, and your denominator always stays the same. So 12 halves is the same as 2 2/5. All right, now we're going to do the opposite. We're going to take mixed numbers and we're going to turn them into improper fractions. So I just call this method around the world. I always lose my pen. Where's my pen? There it is. All right, so you're going to start down here at the bottom. You're going to go around the world. You're going to multiply the denominator times the whole number, and then you add the remainder. So 3 times 4 is 12 plus 1 is 13. This should be a 13. That's not a very pretty 13. And your denominator always stays the same. So 3 1/4 is the same thing as 13/4. Let's try another one. 4 3/4. We're going to go around the world. First we multiply, then we add. So 4 times 4 is 16 plus 3 is 19/4. 19/4. So 4 3/4 is the same thing as 19/4. I was going to convert them into decimals. If you do, by dividing the top number by the bottom number in your fractions, both of these will be equivalent. So 4 3/4 is equal to 4.75. Whoops, wrong button. So if I divided, so if I have, where's my pen? 4 3/4, and I just wanted to show you that these are equivalent. I'm going to say 4 point, and then I'm going to divide that 3 by 4. Well, 4 won't go into 3, but it'll go into 37 times. When you subtract, you get a remainder of 2, bring down a 0. So 4.75. Now these two numbers are equivalent. 3 3/4 is the same thing as 3.75. And then if I divided 19 by 4, I should get the same answer because all of these are equivalent. So 4 will go into 19 4 times. 4 times 4 is 16 with a remainder of 3. I'm going to bring down a decimal, bring that straight up. I'm going to bring down a 0, but bring the decimal straight up. 4 will go into 37 times, and 4 will go into 25 times. So do you see how 4.75, 19/4, and 4 3/4 are all equivalent? They're all the same number, just different forms of the same number. All right, so just a quick little lesson on decimals. All right, so moving on. So today, or this week, I should say, you are going to be dividing with mixed numbers. So remember when we divided proper fractions, you had to keep it, change it, flip it. Well, you're going to have to do that also the same way. You're going to have to do that too here. However, there's one extra step. The first step is to always turn your mixed numbers into improper fractions every single time. All right. So we're going to go around the world. 4 times 3 is 12 plus 1 is 13. So that first number is 13/3 divided by 1/3. So now that I have all improper fractions, either improper or proper, no mixed numbers, now I'm going to keep it, change it, flip it. I can divide 3 divided by 3 and 3 divided by 3, and I get 13 over 1, which is 13. So 4 1/3 divided by 1/3 is 13. All right, let's look at the next one. We're going to make both of them improper fractions. So 3 times 2 is 6 plus 1 is 7/2. And then 4 times 1 is 4 plus 1 is 5. So I convert everything before I keep it, change it, flip it. So now I'm going to keep it, change it, flip it. I can divide 2 by 2 and 4 by 2. Multiply straight across, I get 14/5. And now I want to know how many times will 5 go into 14? 5 will go into 14 2 times with 4 left over. So 2 4/5. The next one, going around the world, 6 times 3 is 18 plus 1 is 19/3 divided by 12 plus 1 is 13/4. And now I'm going to keep it, change it, flip it. Nothing simplifies, so I'm going to multiply 19 times 4 is 36. 4, 5, 6, 7, 76 over 13 times 3 is 39. And let's see, 39 will go into 76 one time. So let's do it this way. 39 will go into 76 one time. And when I subtract, that is a 7 and that is a 3. So my remainder is 37 and that denominator stays at 39. Okay, as when you find out after you do that, if the top number is smaller than the bottom number, then your whole number is correct. Okay. All right, so let's look at this word problem. It says a rectangular cardboard has an area of 21 2/3. That's the area. 21 2/3 inches squared, and a width of 4.5. It says the length of the cardboard box can be found by dividing its area by the width. So that's what we're going to do. We're going to divide the area 21 2/3 by the width of 4.5 to find out what the length is. So we're going to go around the world. 21 times 3 is 63 plus 2 is 65. 65/3 divided by 4 times 2 is 8 plus 1 is 9/2. So now I'm going to keep it, change it, flip it, and I get, what would that be, 130 over 27. And then, oh goodness, I'm way up here, you guys. 130 divided by 27. Let's see. Ooh, this is almost 30. So let's try 4. I don't know. 4 times 7 is 28. 8, 9, 10. Yep. That's smaller than 27, so that works. So it goes 4 whole times with a remainder of 22, and our denominator is 27 inches. So that is the length. The length is 4 22/27. The width is 4.5, and that means the area is 21 2/3. And if I wanted to double check, I can always double check by multiplying the width and the length to give me the area. All right, so you can always check these. All right, so that takes us to the next type of lesson you'll have this week. Make sure you're reading for understanding all of your lessons. You're doing all your practice problems. You're writing down notes. Don't just rely on my videos. These are supplementary to what the Florida virtual curriculum is. So just remember that. It's just a quick reminder. All right, prime number. What is a prime number? A prime number only has two factors. So for example, the number 3, the only two numbers that multiply together to give me 3 is 1 and 3. So it only has 2 factors. It's prime. Now the composite numbers have more than 2 factors, like the number 10. So 10 has factors of 1 and 10, but also 2 and 5. So if you have a number with more than 2 factors, it's composite. Prime numbers only have 2 factors, which is 1 in itself. So let's identify these numbers as prime or composite. So what about the number 5? Does 5 have more than 2 factors? Nope, only 1 and 5. I used the example of 10 already, so we know that's composite because there's 4 factors over here, right, for the number 10. 13, are there 2 numbers multiplied to give me 13? Nope, only 1 and 13, so that's prime. What about 19? You guys do these on your own before I tell you. What about 21? Does it have more than 2 factors? Yep, 3 and 7, right? So this is composite. What about 22? Of course, all even numbers are composite, right? All of them can be divided by 2. So this number is composite. 35, 5 times 7, right? What about 49? Gotta think. 49 is 7 times 7. So it has more than 2 factors. And what about 100? Yes, it definitely has more than 2 factors, right? All right. So what you want to do when you're told to make a factor tree, you want to get it all the way down to its prime factors. So for example, we want to think, what can we divide? I usually start with the smallest number. So can I divide 24? First of all, dividing by 1, it doesn't change anything. If I divided by 1, I'd get 1 and 24. So I always go to the next number. 2. Is 2 a factor of 24? It is. 2 times 12. When I get to a prime number, I circle it. And then I want to know what are the 2 factors of 12. So besides 1, 2 and 6. So there's another prime number. And then 6 has 2 factors besides 1 in itself, and that's 2 and 3. So the prime factorization of 24 is 2 times 2 times 2 times 3. And I can find this by making a factor tree. So if I multiply 2 times 2 times 2 times 2 together, I'm going to get 24. All right, let's try 54. It is an even number, so I know it's divisible by 2. So 2 times 27 is 54. 2 is prime. 2 won't go into 27, but 3 will. So 3 times 9, well, 3 is prime. And then 9, the other 2 factors besides 1 in itself is 3 and 3. So the prime factorization of 54 is 2 times 3 times 3 times 3. And to double check it, you can multiply those 4 numbers together and you should get 54. All right, let's try one more. 36. Well, it's even, so I know 2 goes into it. All right, so 2 times what? 12, right? And then 12 can be divided by 2, 2 and 6. And then 6 is 2 and 3. I messed up because these are not the same number. 2 times 2 times 2 is 8 times 3. What did I do? Oh, it's not 12. Sorry. Let me go back. I messed up. 2 times what is 36? It's not 12. It's 18. I knew I did something wrong because I was getting the same answer here as this one, and that can't be right, can it? So 2 times 18 is 36. All right, so now I know 18 can be divided by 2, 2 times 9, and then 9 is 3 and 3. So what's the prime factorization of 36? 2 times 2 times 3 times 3. So if I multiply 4 times 9 together, I know that's 36. So I know that answer is correct. So you're going to have to make some factor trees. And then that's going to lead us down to finding the least common multiple of 2 numbers. And then we're going to do the greatest common factor. Now there's different ways for teachers to teach these things. And if you ask 3 different teachers, you'll probably hear at least 2 different ways to do this. So I'm just showing you the way I do it. If your teacher in your school does it differently, that's fine. They will work as long as you just find a way that works for you and stick with it. Now, see this word multiple, you have to remember the word multiple is a big number, right? If I say that, goodness, my students are multiplying, meaning my classes are getting bigger and bigger. So multiple is a big number. So basically we want to know what is the smallest number. You see the word least. What's the smallest multiple that these two numbers have in common? Well, basically all I do is I start with with one of the numbers and I start thinking of the multiples. I think of 9 times 1, 9 times 2, 9 times 3, 9 times 4, 9 times 5, 9 times 6, and you can go on forever because multiples will never stop. But after I do a few, I think that's probably good enough. And then I pick the second number, and I always start with 12 times 1, 12 times 2, 12 times 3, 12 times 4. As soon as I find a multiple, the smallest number that they both have in common, then I have just found the least common multiple. They're going to have more than one multiple in common, but we were looking for the smallest multiple they have in common. Okay. Now, the other term that you'll need to know for this unit is greatest common factor. Now, factors are small numbers, right? You need two factors to make a product. So we're looking, this time it's almost like the opposite. This time we wanted the biggest common factor. What do they both have in common? So you can make a prime, you can do a prime, what we call it, a factor tree if you want to, but basically I just start with each of the numbers and I think, okay, what are factors of 9? 1 times 9 is 9. Does 2 times something equal 9? Nope, but 3 times 3 equals 9. And I've just written all the factors of 9, 1, 3, and 9. I don't have to write 3 twice. All right, now I'm going to look at the number 12. What are all the factors of 12? You'll start with 1 and then go up from there. So 1 times what is 12? 1 and 12. Does 2 go into 12? Yep, 2 times 6. Does 3 go into 12? Yep, 3 and 4. And then the numbers would start repeating, right? So all of the factors of 12 are 1, 2, 3, 4, 6, and 12. And we want to know the biggest number they both have in common. Well, they both have the number 3 in common. So 3 is the greatest common factor of 9 and 12. All right, let's practice a couple more. All right, we want to know the greatest common factor. Factors are small numbers, multiples are big numbers. So we're going to start with 64. All right, so let's think of 64. It's a big number, right? So 1 times 64, I'm going to give myself some space. What about 2? 2 times what? 2 times 32. What about 4? Can I divide? 3. Let's see. Nope, 3 is not a factor of 64. What about 4? 64 divided by 4 is 16. So 3 is not a factor, but 4 and 16 are factors. All right, what about 5? Nope. 6? Nope. 7? Nope. 8. 8 times 8. So I'm not going to list it twice. But the reason I put it in the middle is because I know I've reached the numbers that are going to start repeating, because 9, 10, 11, those are not factors. I don't think 12 is a factor. 12 times, no, because 12 times 5 is 60. Is 13 a factor? 13 into 64? Nope, that's not a factor. Nope. And that was 13, 14, 15 is not a factor. And then we'd start repeating. So all the factors of 64 are 1, 2, 4, 8, 16, 32, and 64. Okay, now we're going to do 80. So 80 is a big number. So we're going to say 1 times 80, right? What about 2? Yep, it's even. 2 times 40. What about 3? No. What about 4? 4 and 20. What about 5? Yep, it ends in a 0. So 5 goes into 80 16 times. What about 6? Nope. 7, nope. 8, yes. 8 and 10. And then I think we're done. I don't think 12 is a factor. No, I know it's not. Nope, that's it. All right, so the factors of, so this takes a little time, but the greatest common factor, what do you see? What's the biggest number they both have in common? I see a 16 in both columns. Okay, so that's it. The greatest common factor of 64 and 80 is 16. All right, it takes a little time, takes a little work, but that's it. All right, moving on. Oh, there's one. What about the greatest common factor? So greatest common factor, factors are small numbers. So let's do it again. Let's do 48. 48, the factors are 1 and 48. 2 and what? 24. 24. 3 and 16. 4 and 12. Oh, I almost ran out of space. 6 and 8. All right, so it's 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Those are the factors of 48. And now let's do 12. So 12, smaller number, thank goodness. 1 and 12, 2 and 6. 3 and 4. All right, so what's the biggest number they have in common? I see a 2, I see a 3, I see a 4, I see a 6. Do I see a 12? Yes, I do. 12. The greatest common factor of 48 and 12 is 12. Yep, that's it. All right, you guys. Hope you're doing well. All right, let's read this question or this word problem. It says, Kelly's making gift bags for her friends. She has 48 candy bars and 18 bags of chips. So can you imagine 48, put them on the floor, 48 candy bars over here, 18 bags of chips over here. She wants to make all the bags the same. So she wants the same amount of candy bars and same amount of chips in every bag. What is the greatest number of bags Kelly can make with no candy bars or bags of chips left over? So what are we going to do? So let's start by finding the greatest common factor. So there's 48 candy bars and there's 18 bags of chips. So what are the factors of 48? We have 1 and 48. Might be more space. I have 2 and 24. Oh, we just did this one. I just erased it. 24. We have 3 and 16. We have 4 and 12. And we have 6 and 8. All right. So then I think we've done 18 too. No, I don't think we have. All right. So those are the factors of 48. So let's do 18. 1 and 18. 2 and 9. 3 and 6. And that's it. So what's the greatest number of bags Kelly could make with no candy bars or chips left over? And she wants all of them to be the same. She wants them all to have the same amount of candy bars and the same amount of chips in each. Well, the answer is 6 bags. So imagine if we have 6 bags, 1, 2, 3, 4, 5, 6. We want to make sure our answer makes sense, right? Let me change colors. So if we have 6 bags, that means we have 3 chips. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we'd have 3 bags of chips in each bag. And then how many candy bars? So let's do I'll use green, and I'm not going to put C for candy. I'm going to put B, candy bars. So what would I have in each? I'd have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm tired of writing that. 8, 8, and 8. So I'd have 1, 2, 3, 4, 5, 6 bags with 8 candy bars in each. That's 48 candy bars. And in my 6 bags, I'd have 3 chips in each bag. No leftover candy bars and no leftover bags, and they all have the same amount in them. So yes, my answer makes sense. All right, everybody hanging in there, I hope so. All right, now this says to use the greatest common factor and the distributive property to express 44 plus 16. So in other words, they want us to rewrite this so that it's still equivalent to 44 plus 16. So what is the biggest number 44 and 16 have? Well, 44 only have 4. That's not true. So think about the factors of 44. 1 and 44, 2 and 22, and then 4 and 11. And then 16, we have 1 and 16, 2 and 8. Whoops, 2 and 8, 4 and 4. All right. So basically, the greatest common factor of these two numbers is 4. So we're going to pull a 4 out of both of them. And now think, what times 4 is 44? What's 11? Plus, now what about 16? If I divide 16 by 4, what do I get? 4. So I've just rewritten this, but it's still equivalent to this, what we started with. So if I added 44 and 16, I would get 60, right? 44 plus 16 is 60. Well, 11 plus 4 is 15. And if I multiply 15 times 4, I also get 60. So when it says write it in a different way using the greatest common factor, that's what you're doing. You're literally pulling out that greatest common factor, you're dividing by the greatest common factor, and you're writing the what's left as a sum of two numbers. So what about 48 and 18? Earlier we did these two numbers, and we decided that the greatest common factor of these two numbers is 6. So let's do that. Let's pull out that greatest common factor, 6. And now what is 18? 6 times what is 18? That'd be 3. And then 48 divided by 6 is 8, right? So if I added these two numbers up here, I would get 66. Well, right here, 8 plus 3 is 11, and is an 11 times 6 also 66? So we've written it, we have rewritten it. It's still equivalent, but we've written it using the greatest common factor. All right, what about 48 and 12? Well, we know our greatest common factor because we've done both of these numbers of these two numbers is 6. So no, it's not 6. It's 12. It's 12. Both of those numbers are divisible by 12. So 48 divided by 12 is 4, and 12 divided by 4 is 1. So I have rewritten this sum using the greatest common factor. So let's double check it. If I added these two numbers together, I'd get 60. Well, if I did parentheses first, 4 plus 1 is 5, and 5 times 12 is 60. So I have rewritten it using the greatest common factor. And now it's asking us to do the opposite. So to do the opposite, we're going to use that distributive property. What we're going to do is distribute the 8 to the 2, and then we're going to put plus, and then we're going to multiply 8 times 7. So 8 times 2 is 16. 7 times 8 is 56, and I have rewritten it so that it's equivalent. So now imagine if we added 16 and 58, we would get 74. So let's make sure it works here. Well, yeah. So 7 plus 2 is 9, and 9 times 8 is not 74. What did I just do wrong? Oh, it's 56. Sorry. Hold on. Sorry. I put 58, but it's 56. 8 times 7 is 56. See, good thing I checked my answer, right? Because I knew my answer wasn't right because I was trying to check it. So now it should be equivalent. So if I add 16 and 56, now I get 72. So then if I double check it, 7 plus 2 is 9, and 9 times 8 is 72. So this is going to be the right answer. This is the opposite directions as this one. All right, I think that's it, you guys. Yep, that's it. So you guys are going to have your first test this week. So good luck to you. If you need me this week, let me know. Make sure on Wednesday you have completed your study guide. And when you watch my video for Wednesday, all you're doing is checking your answers and seeing if you got everything right. Hopefully you did. If not, you're going to see why you missed it. All right, everybody, I will talk to you later on. Have a great week.